Sometimes in a system of equations, one line exactly parallels another line. In this case, since the solution to this system is where they cross, and since they're parallel, they will never cross, this system has no solutions. Sometimes one line will be exactly on top of the other line. In this case, since wherever they cross is a solution, there are an infinite number of solutions. At other times, one line merely crosses another line in one spot. These systems have only one solution. Let's notice a few things about the systems. In the parallel lines, they must have the same slope, same steepness, that's why they're parallel. In the second system, since they are identically the same line, they also must have the same slope. The last system have different slopes, which is why they end up crossing in one spot. In the first system, they cross the y at different points. In the second system, they cross at the exact same point since they're the same line. In the third type of system, it doesn't matter if they have the same y-intercept or not. Sometimes the solution will be on the y-axis, so there will only be one same y-intercept, but most of the time, if it's off, there will be two. If you try to solve a system like this numerically, you will end up with a contradiction, something like 5 equals 0, which is simply not true. If you try to solve the second sort of system using numbers, you'll end up with an identity, something like 4 equals 4, which is always true. We're used to solving the third type of system where we end up getting our variable equaling some number. So when checking a system of equations, first check to see if the two lines have the same slope. If so, it's going to be either no solutions or infinite solutions. Next, check to see if they have the same intercept. If they do, it's infinite solutions. If they don't, it's no solutions. If there wasn't the same slope, you know it's going to be one solution.